Okay, so the solution to this one, which you should be able to do because you have done things like this in National 5, is the first thing to do is to find the total current, which is I1, which is this one here. Okay, so to do that, you want the total voltage divided by the total resistance. So you need to find the total resistance. So it's a combination of series and parallel resistors. So what I've done there is I've said the total resistance is going to be the 8 ohm plus the total of those parallel, those two, which I've called RP, plus the 10 ohm resistor. So I found out what the total of those two parallel resistors are, which is 6 ohms. So remember 1 over RP equals 1 over 10 plus 1 over 15. Remember to 1 over at the end to get your 6 ohms. So the total current I1 is VT over RT. So 12 divided by that total resistance, so 8 plus 6 plus 10, which comes to 0.5 amps. Then I would find V1, which is here. So V equals I1 times R, the resistor here. So V equals 0.5 times 8, which is 4 volts. So V1 is 4 volts. Then I'd go for V3, which is over here. So V equals IR again, using 0.5 amps times by 10. So that's 5 volts. 5 volts. Then to find V2, well, we've got a total of 12 volts, so V2 is just the leftover. So that 12 volts is shared between here, here, and here. So 12 volts, take away 5, take away 4, or as I've written, 12 volts, take away 5 plus 4, which is 3 volts. So V2 is 3 volts. Then now you've got that V2, you can then work out these two currents using I equals V over R, because this gets 3 volts and this gets 3 volts. Remember, they're in parallel, so they'll both get the same, so they'll both get 3 volts. So to find I2, which is this one here, it's V over R, so 3 divided by 10. And to find I3 is V over R, so 3 divided by 15, and 0.3 and 0.2. So 0.3 amps, 0.2 amps. And that's all your unknowns known, V1, V2, and V3, and I1, I2, and I3.